Vanadium pentoxide, which is used as the catalyst in contact process, can get poisoned. That's the reason it's very important to remove all the arsenic, and FeOH thrice is the one which is used to remove arsenic impurities. So what is the half-life period for zero order reaction? It is A/2K, isn't it? Welcome back, my dear students, for part 2 of Karnataka CET 2009 question paper. So we'll start with the 21st question. The order of stability of metal oxide is option A, Fe2O3, Cr2O3, Al2O3 and MgO. The next option you can see, it is Fe2O3, Al2O3, Cr2O3 and MgO. Then we have Al2O3 which is the lowest, and then Cr2O3 which is the highest, and Cr2O3 and Fe2O3. You have to just know the Ellingham diagram to tick the correct answer. In that you can see the order of the stability of metal oxides is option A, which is correct. That is, Fe2O3 is the least and magnesium oxide is the highest. Okay. So next question is, the temperature of slag zone in the metallurgy of iron using blast furnace is option A, 400 to 700 degrees Celsius, option B, 800 to 1000 degrees Celsius, option C, 1200 to 1500 degrees Celsius, and option D, 1500 to 1600 degrees Celsius. So they are asking, what is the temperature of slag zone in blast furnace for extraction of iron? It is 800 to 1000 degrees Celsius. Alva? Correct alva? So option B is the correct answer. Next question. The function of FeOH thrice in contact process is to remove moisture, to remove dust particles, to remove arsenic impurities, to detect colloidal impurities. FeOH thrice, that is ferric hydroxide, is there to check the arsenic impurity. Even if small amount of arsenic is there, vanadium pentoxide, which is used as the catalyst in contact process, can get poisoned. That's the reason it's very important to remove all the arsenic, and FeOH thrice is the one which is used to remove arsenic impurities. Okay, so option C is the correct answer. Next question. In which of the following NH3 is not used? Correct question nodbeku. Not used kelta idare. Option A, group reagent for the analysis of fourth group basic radical. We use, correct? No. Then group reagent for analysis of third group. There also we are using. Tollens reagent also we are using. Only Nestler's reagent we are not using, because Nestler's reagent used to detect ammonium ion. Alyak ammonia use martevi. So obviously it is not used. So Nestler's reagent is the correct answer. Okay. Next question. Argon is used in high temperature welding, in radiotherapy for treatment of cancer, in filling airships to obtain low temperature. See, argon is not radioactive. You can't use there. In filling of airship, it's not the lightest gas. To obtain low temperature is also wrong. To get high temperature in welding is the correct answer for argon. Next question. The incorrect statement in respect to chromyl chloride test. So you have to just recall the chromyl chloride test. Option A, formation of chromyl chloride. Option B, liberation of chlorine. Option C, formation of red vapors. Option D, formation of lead chromate. See, you can see the incorrect statement. In chromyl chloride test, chromyl chloride is obtained. Red vapors you get, it forms lead chromate. Liberation of chlorine is not there. So this is the incorrect statement about chromyl chloride test. Okay. We'll go to the next question. The magnetic moment of transition metal ion is root 15 bm. Therefore, the number of unpaired electrons present in it is 1, 2, 3, 4. See, it is root 15 is equal to root of n into n plus 2. And if you solve for n will be 3. Okay, so the option is C, 3 unpaired electrons. Fine. Next question. The IUPAC name of CONH35ONO2 plus is, first we'll calculate the oxidation number so that we can filter out the wrong options. Okay, so this is X plus 0 plus ONO minus 1 is equal to plus 2. So X is equal to plus 3 is the answer. So plus 3 option erade iradu. Option A ಮತ್ತೆ option D. Penta-amine nitro-cobalt 3 ion, penta-amine nitrito-cobalt 3 ion. It is ONO. So oxygen is the donor. So it is nitrito. Correct alva? So it is option D. Penta-amine nitrito-cobalt 3 ion. The oxidation state of iron in the brown ring complex is given is plus 2, plus 1, plus 3 and 0. So if I calculate the oxidation number here, it is X plus 0 plus 1 plus minus 2 is equal to 0. So this is minus 1, X is equal to plus 1 barutte. Correct alva? Now that is if you know that NO, nitrosyl, is having a positive charge, or the ligand is the one which is positively charged. But if you calculate just like nitric oxide, that is 0, it's neutral. If you calculate, what will you get? X plus 0 plus 0 plus minus 2 is equal to 0. X is equal to plus 2. So actual correct answer idu. But eradunu correct agi kottidare. Okay, if you see your answer key, you have option A and option B as the correct answer. So either of one if you have ticked, you will get the marks, as it can be calculated like this. Okay, next question. The correct statement with regard to H2 plus and H2 minus is, H2 minus is more stable than H2 plus. H2 plus is more stable than H2 minus. Both H2 plus and H2 minus is equally stable. Both H2 plus and H2 minus do not exist. So the correct statement which is more stable than the other we have to get. So first of all, hydrogen H2 only 2 electrons is there. So H2 plus means it has got only 1 electron. So it is sigma 1s1 and sigma star 1s0. Only 1 electron is there. Okay. Then H2 minus anta helidre it contains 3 electrons. So it is sigma 1s2 and sigma star 1s1. So if I calculate the bond order here, it is 1 by 2, it's 0.5, and here it is 2 minus 1 by 2, so it is again 0.5. So bond order is same for both. Then how can I tell the stability? You see here the antibonding molecular orbital has 1 electron, here no electron at all. So H2 plus is more stable than H2 minus. Why is it so? Because in H2 plus antibonding electron illa, H2 minus one electron ide. Based on that we are telling that H2 plus is more stable than H2 minus, and option B is the correct answer. Okay, we'll go to the next question. Arrange the following in increasing order of their bond order. Okay, so O2 has got 16 electrons, O2 plus it's got 15 electrons, O2 minus has got 17 electrons, and O2 2 minus has got 18 electrons. Now bond order with just the number of electrons I can tell. 14 electrons andre bond order is 3. So 2 ಜಾಸ್ತಿ ಮಾಡ್ತೀನಿ 16 ಅಂತ ಹೇಳಿದ್ರೆ 2, ಇನ್ನು 2 ಜಾಸ್ತಿ ಮಾಡ್ತೀನಿ 18 ಅಂತ ಹೇಳಿದ್ರೆ 1, 2 ಕಮ್ಮಿ ಮಾಡ್ತೀನಿ 12 ಅಂತ ಹೇಳಿದ್ರೆ 2, 2, okay, 10 ಅಂತ ಹೇಳಿದ್ರೆ 1. So I have 15 and 17. 15 ಎಲ್ಲಿ ಬರುತ್ತೆ? 14 and 16 ಮಧ್ಯದಲ್ಲಿ. It should be 2.5. Then O2 minus is 17, so it is again 1.5. 18 is 1 and 16 is 2. So now you see which is the correct way of arranging it. increasing order of their bond order. O2 plus ಗೆ ಜಾಸ್ತಿ ಇರೋದು. So O2 plus ಬರಬೇಕು ಎಂಡಲ್ಲಿ. So it should be option C, but we will check again. O2 minus is 1, O2 2 minus is 1, O2 minus is 1.5, O2 is 2 and O2 plus is 2.5. So option C is the correct answer. See, in this question, what did I do? I didn't go to see the options at all. Directly I calculated, because looking into the options here is quite confusing. O2 minus O2, 1 negative charge, O2 plus O2. So it is quite confusing here. Just calculate the number of electrons and calculate the bond order. You will get the answer. Which is the correct answer? Gottid mele option nodi tick madi. That is much easier and it is time saving also. Okay. We'll go to the next question. 2 grams of radioactive sample having half-life of 15 days was synthesized on 1st January 2009. The amount of sample left behind on 1st March of 2009, including both the days, is. So we need to calculate the amount of sample left behind. So for that, formula is amount of sample left behind is initial into 1 by 2 to the power n. Now what is this n? N is number of half-lives and initial concentration is 2 grams, I know. So 1 by 2, I have to find out the number of half-lives. I know that half-life is 15 days and 1st Jan in the 1st March 2009 varge ಎಷ್ಟು ದಿನ ಇದೆ? Number of days, it is 60 days. Correct, no? You sit and count, you will get 60 days. So number of half-lives is equal to number of days is 60, half-life is 15. So this is 4. So number of half-lives, n value is 4. So adannu illi haktini. So you will get it as 2 into 125 grams. So the answer is option D. It is 0.125 grams. Okay. 33rd question. For a chemical reaction A giving B, the rate of the reaction is 2 into 10 power minus 3 mole per dm cube per second when the initial concentration is 0.05 mole per dm cube. The rate of the same reaction is 1.6 into 10 power minus 2 mole per dm cube per second when the initial concentration is 0.1 mole per dm cube. The order of the reaction is. So we have to find out the order of the reaction. So here, how do we do it? See, the rate of the reaction is 2 into 10 to the power minus 3 and the initial concentration is 0.05 to the power n. I don't know the order, that's why I'm taking it as n. And one more is 1.6 into 10 to the power minus 2 is equal to k and initial concentration is 0.1 mole. Okay, so I'll take this as equation 1 and equation 2 and I will just take 2 by 1, or I can take the other way around also, nothing will happen. K and K will get cancelled. So 0.1 to the power n, 0.05 to the power n, K and K gets cancelled, and here it is 1.6 into 10 to the power minus 2 divided by 2 into 10 to the power minus 3. Move 1 point, 10 to minus 3 minus 3, you will get it as 8, and this if you divide you will get it as 2, and 2 to the power n is equal to 8. So 2 to the power 3 is, 2 to the power n is equal to 2 to the power 3. So n is equal to 3. Order is 3. Option A is the right answer. So I hope you have understood how to solve this. We'll go to the next question. For the decomposition of the compound A at 600 Kelvin, the following data were obtained. That is, AB, the number of moles per dm cube is given, and the rate of decomposition, the rate of the reaction is given. The order of decomposition of AB, we have to find out. So what is happening here? AB is getting decomposed. Okay, so they've given the molar concentration, initial molar concentrations and the rate accordingly. So how do we solve this? See, for this is the concentration and this is the rate, this is the concentration, this is the rate. Now here I'll take this to the power n and this is to the power n. We know it is equal to the rate. This becomes the equation actually. Correct, no? Now what we do is, I'll take this as equation 1 and this is equation 2. So I'll do it as 1 divided by 2. So it will be 0.4 to the power n divided by 0.2 to the power n, which is equal to 11.0 into 10 to the power minus 8 divided by 2.75 into 10 to the power minus 8. This and this gets cancelled and this will be 2 to the power n and which is equal to 4. 2.75 into 4 is 11. Okay, so it is 2 to the power n is equal to 2 to the power 2, n is equal to 2. So the order is 2. Option B is the right answer. So it's very easy. If you just relate here in the table or in the given data, just take it as equation 1 and 2 and divide the two equations, you will get the correct answer. Okay, so we'll go to the next question. The rate equation for the reaction A giving B, R is equal to Ka to the power 0. If the initial concentration of the the reactant is a mole per dm cube, then the half life period of the reaction is, see, first observe, rate is equal to Ka to the power 0. So it's a zero order reaction. So what is the half life period for zero order reaction? It is A by 2K, isn't it? So option C, direct, factual, ನೀವು ಕಲ್ತಿದ್ದೀರಾ derivation. So for half life period of the reaction is A by 2K. Okay, so option C is the correct answer. Fine, we'll go to the next question. 30 cc of M by 3 HCl, 20 cc of M by 2 HNO3 and 40 cc of M by 4 NaOH solutions are mixed and the volume was made up to 1 dm cube. The pH of the resulting solution is option A 1, option B 2, option C 8, option D 2. So we have to find out the H plus ion concentration and see what is the pH. Okay. So first we'll find out the milli equivalence of H plus and OH minus. Okay. So milli equivalence of H plus ion is 30 cm cube into what is the molarity 1 by 3 plus 20 cm cube into what is the molarity 2. So if you see this, you will get it as 20. Correct? So it is milli equivalents are 20 milli equivalents. Milli equivalents of OH minus we will do, that is 40 into 1 by 4 which is equal to 10. So therefore when both of them are reacting, we are mixing both. What is the amount? H plus ion is more. So the amount of H plus ion which is left is 20 minus 10, that is 10 milli equivalents is left. But H plus ion concentration, you read the question, it is made up to 1 dm cube. Andre 1000 ml is there. So it is 10 divided by 1000 which is equal to 10 to the power minus 2 and H plus ion concentration is 10 power minus 2. So pH is 2 and the answer is option D which is the correct answer. Okay. We'll go to the next question, that is the 37th question. An aqueous solution containing 6.5 grams of NaCl of 90% purity was subjected to electrolysis. After the complete electrolysis, the solution was evaporated to get solid NaOH and the volume of 1 molar acetic acid required to neutralize NaOH obtained above is option A 100 cm cube, option B 200 cm cube, option C 1000 cm cube, option D 2000 cm cube. So what do we need to find out? We have NaCl solution of 90% purity which was got converted into NaOH solution. Then only NaOH was obtained. Then that NaOH was neutralized to acetic acid with acetic acid. And what's the volume of acetic acid required to neutralize NaOH is what we need to find out. So first I'll find out the weight of pure NaCl. Okay. So the weight of pure NaCl is equal to 6.5 into 90 by 0.1. Okay, that is because it's 90% purity, you will get it as 5.85 grams. Okay, next we are going to find out the number of equivalents of NaCl. It's the weight by molecular mass. Okay, weight is 5.85, molecular mass is 58.5. This is nothing but 0.1, isn't it? So all the NaCl was converted to NaOH. So number of equivalents of NaOH is also 0.1. Therefore, that is number of equivalents of NaOH also is equal to 0.1. Now we'll take the formula N1V1 is equal to N2V2. So NaOH is 0.1 into 1000. That's why we got 0.1 equivalents, and normality of this is 1 into volume we need to find out. So it is 0.1 into 1000 divided by 1, which is equal to 100 cm cube. So the answer is option A, which is 100 cm cube. We'll go to the next question, 38th one. The standard electrode potential for the half cell reaction are, the standard reduction potential of zinc and iron is given, and the EMF of the cell we need to find out for this reaction. Here, anode is where oxidation takes place, that is loss of electron. So zinc is the one which is the anode, and iron is accepting electron, that is why it is reduction or it is the cathode. Okay, so E cell is equal to E naught of cathode minus E naught of anode. This is the formula, and cathode is iron, which is minus 0.44 minus of minus 0.76. If I solve this, I'll get it as 0.32 volt. That is minus into minus plus I'll get, so it is plus 0.32 volt, and option B is the correct answer. Correct? Okay. We'll go to the next question. 10 to the power minus 6 molar NaOH is diluted 100 times, and the pH of the diluted base is option A between 6 and 7, option B between 10 and 11, option C between 7 and 8, and option D between 5 and 6. So you need to tell between which is the pH. We do not calculate the exact pH here. Okay. So first thing is, NaOH was diluted. Correct? So OH minus ion concentration is 10 to the power minus 6 by 10 to the power 2, that is 10 to the power minus 8. Correct? And because the OH minus ion from water also it is given, we have to calculate or add up even that. So it will be OH minus ion concentration from NaOH is 10 to the power minus 8 plus 10 to the power minus 7 from water. So 10 to the power minus 8 I'll take common plus 10 here. So you will have 11 into 10 to the power minus 8. So we have to take the log of this. That is because POH is equal to negative logarithm of OH minus ion concentration. So this is negative logarithm of 11 into 10 to the power minus 8. So this is log A into B is log A plus log B. So minus log 11 plus minus 8 log 10, that is minus 8 itself. Log 11, it will be 1.04 some number is there. Just consider 1 point some number is there, and this is minus 8. So minus into minus it's plus. So it is 8 minus 1.04, that is somewhere around 6.9 and so on. So this is POH. So what will be the pH? pH is 14 minus POH. So 14 minus 6.9 if I consider, it to be? So it will be 7.1 something, or I can tell approximately between 7 and 8. So it is between 7 and 8, and option C, between 7 and 8 is the correct answer. You don't have to come to the exact answer. That's the reason I've just approximated here. Okay. Next question. 40th one. In the electrolysis of acidulated water, it is desired to obtain 1.12 cc of hydrogen per second under STP conditions. The current to be passed is option A 19.3 amperes, option B 0.965 amperes, option C 1.93 amperes, and option D 9.65 amperes. So in this equation, if you see, H plus ion will accept electron to give hydrogen atom. But if you want hydrogen gas, you require 2 H plus ion and 2 electrons, isn't it? So N is equal to 2, which you need to remember. Now first I'll calculate the number of moles of hydrogen. Okay. Number of moles of hydrogen is 1.12 divided by 22,400. So I'll keep it as it is. Now I'll calculate the number of equivalents of hydrogen. Number of equivalents of hydrogen is 1.12 divided by 22,400 into 2, because 2 electrons is there. So this if I do, I will get the answer as 10 to the power minus 4. Okay. So that's the amount of Faraday which is required. I have to calculate the current to be passed per second I want. So therefore, current to be passed per second is 96,500 into 10 to the power minus 4. So this will be equal to 9.65 amperes. Okay. So the answer is 9.65 amperes, which is option D. So I hope you have understood how to solve this problem. Thank you, my dear children. Stay tuned for part C of Karnataka CET 2009 chemistry question paper.